Here we have a 1946 Zenith Trans-oceanic clipper, multi-band radio, and these were, in my opinion, the best looking of the transoceanic radios made between 46 and 81. This particular series, which is the G005, was made between 46 and 49. I don't know which. I believe this is one of the earlier ones, probably 46 or 47. Anyway, this particular radio was the better of the two that I bought. This case is in better condition than the other one because the vinyl leatherette is still intact. It just needs to be colored with some dye. And right down to the bottom panel has come off and it'll need to be glued. But this radio is very restorable, and we'll just need some cleaning, and maybe the front plastic pieces will need some Armor All, and that'll shine them up. That brass I'm not going to do anything with, and doesn't even need cleaning. And this little panel comes down, and this has a patina which I don't want to change. It's really nice. And the top comes down like this for transportation, and this latches together, and that I might just take a little bit of brasso to that, but it's got a really nice patina. I don't want to lose that. As far as this all is smooth, and it isn't broken in any place, this leatherette, so I'm just going to take some shoe dye and just start coloring it. The electronics I'm going to do later, and that will be the most complex part of it, this restoration job. On the underside here, I'm going to have to put some glue into that gap and glue it, push the little nails in, and that should fix. It's like that on both sides of the bottom, so I'm just going to have to fix that. A little bit of carpenter's glue on this, on the other side, and just push it together and just leave it overnight with a weight on top, and both sides should be nice and strongly glued together by morning. I replaced the broken handle with the handle from the other radio, which was in very good condition. It even came with the original brass spacers, as you can see right there. I took some brasso to the front latch, and it ended up looking pretty good, and it kept the original patina, which looks appropriate for a radio that's 75 years old. I've taken shoe dye to the rest of the cabinet, but some parts still I haven't done yet, like this area here. It looks worn, but once I've taken the shoe dye to it, it will look pretty good, like this here. Now I'm going to finish off right the last panel. I'm going to add blacken off the edges with the shoe dye. See here. There. There. Still showing some wear marks through the vinyl. If I just go at this for a few minutes, it will completely turn out like it's never lost its color. I put the back door on with these 4 screws here, and I've shined up the back panel or door with the shoe paint, and now this is what it looks like on the back. So it looks really nice. It's really accepted the shoe dye or paint, and it blends in well with the rest of the radio cabinet. I took some Armor All protectant and wiped the wave magnet antenna, which is right up at the top of the radio. It's part of the front, and it lifts up and reaches over the handle. So it looks a lot better than it did. And I'll add a little more once it dries. I added some Armor All protectant to the handle, which is made of some kind of plastic, and it improved its appearance. It gave it a bit of a sheen. And I added a second coat onto the antenna, the AM antenna, and I gave a little bit of a coating to the top of the antenna there. It's right here, it's a cap, and that has come out pretty good too. So put that back there. Now let it all dry and see how it comes out after a day or so. The front piece of the radio here had been removed, and I washed it, treated it with Armor All, and I replaced the plastic piece that covers the frequency dial, and now I'm going to reattach it to the radio. Here, the front piece of the radio frequency dial has been put in the radio case, and all I need to do is tighten down these 4 screws here, and then the cabinet itself will be finished. The radio looks really nice, all shined up with the bottom shelf dropped down and the instruction manual down there. And the front replacement plastic piece looks really good, and all the chrome is really shiny. So the next step will be to do the electronics. I washed all the tubes, and I tested them all and found only one was bad. So here's how I test the tubes in this tube tester here. I press the red button, and I look up a booklet, and it tells me all the settings of all these dials and how to set the bias, and the thing called English, and the filament, and that's the voltage. These are 1.5 volt filaments. So there's the tube. I put it into the appropriate socket, and here is the scale I should look at. It's it's the 3000 scale, and I'll press the red button, and the tube should read up to 925, between 525 and 925. So there we are. It's reading about 800. So that reading is well within the range of the recommended amount of micromhos, which is now called microsiemens, dynamic mutual conductance, which is basically the gain of the tube. So that tube's excellent. I only had one bad tube. So now I have enough out of 15 tubes. I only need 8 tubes for the radio, and I've got lots of spares. Here we have the radio chassis taken out. I've pulled out all the tubes, and I've given it a bit of a vacuuming, and you can see it's in very clean condition. The dial turns. Everything's intact. It doesn't seem, it's even got its original battery. There's a little bit of the speaker there's coming away. The speaker surround is coming away. That'll need to be glued, but the speaker itself is in very nice condition. No tears or anything. Next, I'll look at the underside of the radio. Here we see the underside of the radio. It's never had any work done on it, and you can see all the original capacitors and resistors there, and everything's going to have to be replaced. You can't trust any of these old paper capacitors. That one's going to go, that one, that one, that one, that one, there, that one, that one, that one, that one, the one down there, that one has to go, that one, and that one, and that one there, and I think there's one on the top there too of the radio. Capacitors like this one and this one are micas. They usually don't have problems. But the problem is if you leave one like this in, what can happen is if they're separating a high DC voltage from a low DC voltage, like let's say a coupling capacitor is going from a plate, which is let's say at 175 volts, and it goes to a grid of the next tube. The grid normally is at a very low voltage, and if the capacitor starts to get leaky, you can get the high voltage starting to bring the voltage on the plate up, and it can cause a tube to turn on hard, and it can burn out the tube. So that's why whenever you're restoring these old radios, don't trust these old capacitors. They are cheap to replace, and you'll be saving yourself a lot of headaches. Even if you leave these in, or some of them in, you'll have problems like the radio will be playing, it'll be clicking for no reason, and then the sound will drop, it'll come back again. All sorts of annoying characteristics like that. It can also get very crackly, lose sensitivity. So there's no point in keeping the old capacitors in. As I said, the only ones that don't need to be changed are those micas, and they're the square ones. They last and they don't change value. Later on, once the capacitors are replaced, if the radio still has problems, then I will go in and check resistors. They sometimes change value. Usually they do change value, but often they don't need to be replaced because the values haven't changed to the point where they affect the performance a whole lot of the radio. Anyway, we'll go through all that. Another thing that has to be replaced is on the top side of, probably see it, I think it's right there, and further into the radio anyway, are the two electrolytics, and I'll leave them on the top just for show, and I'll bypass them on the bottom with modern electrolytic capacitors. Anyway, this is going to be a bit of a challenge to change all these capacitors. Another thing that I'm going to point out is some of the things on the coils. right down here, that coil and that coil, they seem to be loose, and I'll have to glue them back in place. And the main problem I see here is the band switching, the wafer here made of bakelite. This is all bent here, and it might have difficulty going into certain bands. So what I'm going to have to do is try and maybe I'll try and fix that with some epoxy, and if that doesn't help, I'm going to have to replace this whole section, change it from the other radio. That'll be a bit of a job because it's quite a bit of soldering that'll have to come off, but that'll only be in an extreme case. I'll do that. If I can't fix what's this bent piece of bakelite here, might be broken inside, you never know. Anyway, we'll worry about that later once we change all the capacitors. I notice here, right here, there's another paper wax capacitor, and is that one in there? I think that one in there is a mica, but that one definitely will need to be replaced too. These three electrolytic capacitors are in the power supply. You've got 3 resistors here, and the voltage is just smoothed and lowered, and by the time it comes out here, it's a nice clean DC waveform. So this here, I'm going to have to replace each one of these, but I'm going to replace them with higher value capacitors. Those look like 40, 20, and 10. I'll probably replace them each with a 50 or 100. And it'll give better performance. This R18 has cracked, so that'll have to be replaced. And I'll show it over here. If you could just see right there, this here is R18. It's just a big wire wound resistor. And here is the 2 electrolytic capacitors in here. And I'm going to remove this. It's a big can that sits on the top of the chassis, and I just want to keep it original. I'm going to use that and put 2 modern capacitors inside it so it looks original. And I'll replace this big wire wound resistor here. The reason that this cracked and overheated was because this capacitor assembly would have shorted and drawn a very large amount of current through the rectifier tube, and this just heated up and cracked. Maybe someone left it on for a while, and then it would have got completely inoperable. So the first capacitor first 2 capacitors I'm going to replace are these here. After a lot of trouble, I managed to drill out the insides of the capacitor can, and I was able to find capacitors that were exactly of the values that I wanted. So I don't have to put in 100 microfarad. I can put in exactly what the circuit was designed for. So I'm going to take these little electrolytics, and I'm going to put them in such a way, tie them together, and have wires coming out so that I can insert them in that capacitor can. And then I'll seal them off with epoxy, and then that can be mounted on the chassis of the radio, and it'll look original. Here I've wired 2 22 microfarad capacitors in parallel, so I get 40 from the white wire. The common is the black wire, and I'll get another 22 microfarads between the common wire and the green wire. So I'm going to roll them up and glue them together and put them in the capacitor can. So here I've installed the capacitors in the can and installed the can itself on the chassis. And as you can see, with the wires protruding through the chassis, I'm measuring 22.3 microfarads between the black wire and the green wire. Now let's just move the green wire and measure the black wire to the white wire. And now you can see that it's 44.3 microfarads. So now all I have to do is wire in the capacitors and go to the next step. Here I stuffed this electrolytic can. I took it out and I stuffed it with modern capacitors. And this one here wouldn't fit, so I had to put this underneath the chassis. And over here, rather than drilling this can out, which takes about 2 hours, I just put these electrolytics underneath the chassis and just wired them in. That saved a lot of hours. This would take about 2 hours to drill out, so I just left it the way it was and disconnected the positive leads and wired these electrolytics in. So the next thing I'm going to do is I'm going to replace these paper wax capacitors, and that I'll replace as many as I can. Right over here, when I'm getting into the RF section, if there isn't much DC voltage across them, I'm probably not going to worry about them. If the radio works fine, I'm not going to, because these ones here are all for coupling or negative feedback, and they usually have a substantial DC voltage across them, and it becomes a safety issue. It could destroy a tube. But if they are isolated in the RF section over here, like this one, or there's a few on the top, if they don't affect the operation of the radio, I'm not going to replace them. I'll just keep them as they are if there's just AC going through them. But I'll after I replace all these wax capacitors, I'll see what needs to be done. I'll see how the radio works. Here we've completed the capacitor replacement. There's a lot of trouble replacing those down inside the RF section there. And I've plugged in the radio, and I don't hear any sound, very slight hum, but this resistor here heats up. This resistor comes from, it's connected to right here, which is the first stage of the series of capacitors that smooth out the power that comes in from the line. So this here, wrong resistor, this resistor here, I'm going to have to figure out where there must be a short somewhere. Maybe there's some rotten wire in here. Or maybe I've done something wrong, but I'll have to trace that through and find out why that's overheating. Here I have the radio that I'm working on, side by side with the radio that hasn't been altered. It's got the original wiring in it, so I can follow. There I'm measuring the resistance across the output coil, and it's 469.7 ohms, so it's not shorted. So I'm going to go through, I've removed a lot of the wiring that I put in, and I'm checking resistances in there to see if any of the resistors are shorted, and I'm also going to check the tubes and see if there's something I missed. I went in and found the problem why this R17 was overheating. I had made a mistake, and it was shorting out. So now I plug the radio in, and it sounds, there's no sound, but there's no smoking. Nothing is smoking at all. Nothing seems to be getting too hot. So I'm just going to see why there's no sound coming out of the speaker. The incoming rectified DC voltage right down here where the yellow lead. I'm measuring that between ground and the part where it's rectified, right between the resistor, right there, the brown resistor. At that point, it should be 110 volts, and it's correct. Now I'm going to go further down and see what voltages it measures along the resistor right there. Those are two resistors. So the first resistor in the Pi-type filter is that one, and then there's two more in series, and I'm just going to measure the voltages. Right at the output of the brown resistor there, I'm getting 104.3, which might be a little bit low, but it seems to be fairly normal. Measuring from the middle of the resistor to ground, I'm getting 61.9 volts, which is quite rather low. So I'll have to look into that and see why that's reading a bit on the low side. Measuring on the last resistor there at the output, I'm measuring 18.78 volts. That seems a bit low to me, so I'm going to go through and see if there's a excessive current or voltage drops. Maybe there's some resistors that aren't the right value. Anyway, I'm not getting any sound out of the radio at all at this point, but nothing smoking, no smells, so we have no shorts in there. I'm measuring from ground to the plate of one of the output tubes, and I'm measuring 63.6 volts. Now, it looks like on the plate on the schematic, it looks like 81 volts. Although if this radio was working, even with 20 volts less, I would hear something coming out of the speaker. Here's the output tube that I was measuring, and that looks like 81 volts to me, but it could also be 61 volts. It's very hard to tell from some of these schematics. 81 makes more sense to me because I looked at the specs for that 1LB4 tube, and the plate voltage is 90 volts. So 81 makes sense to me. So I'm just going to have to dig further into and do some troubleshooting and see, and maybe find another schematic that'll give me the voltage that should be. I'm testing the radio out, starting with the speaker, and I've put a signal generator with 1000 hertz test tone on the speaker, and the speaker does work. The next point I'm going to check, I'm going to feed a signal in from here and here, the two plates of the output tubes, and I'm going to see if I can feed a signal to the speaker. If I can't, if the signal doesn't get through, either the input coil or the output coil or something in here, I know the speaker's working, so something in the transformer is not working, even though I tested it, and it seemed to have continuity. I basically checked with an ohm meter across the speaker coil, and if this coil here was open, it could mean that I was just testing this coil here. So anyway, I'll feed a signal into here and see if I can hear it on the speaker. If not, then we know that this speaker or this transformer is open somewhere. I'm feeding a 1000 hertz signal source into the output audio transformer, and I'm hearing nothing from the speaker. While I tried it on the other radio, which I've got the old radio that hasn't been modified, I hear something from the speaker. So what I'm going to do is I'm going to switch the audio transformer from the parts radio to this radio and see what happens. Before I removed the output transformer, I thought it checked good input. You know, the input coil checked, it had good resistance, and the output rarely goes. So I thought maybe I'll check, since the radio is so old, I'll just check the connections to the speakers, and also there's a, right down there you can see there is an earphone jack. It uses the old-fashioned double earphones. They have separate plugs. So I bypassed it with the signal generator going, feeding an input to the input of the transformer, and I heard that the speaker came to life. So I realized that there's a bad connection in there. So I just sprayed some deoxit type, and I manipulated the controls, manipulated the connections, and put an old-fashioned earphone that I stuck in there a few times, and it came to life. So that was the whole problem. So it really pays to pay attention to detail and consider everything, because in these old radios, anything can go. But more can be attributed to bad connections than anything. I think I'll end up just redoing all the connections in this radio, because a lot of them look like they were done with acid solder, and acid solder causes a lot of problems over time. The acidic solder, that's non-rosin solder, changes the characteristics of the lead and makes quite bad connections actually over time. So if you resolder all the connections and add in a little bit of modern solder, you make good connections again. Right now I'm feeding a signal into this point here at the volume control, and the signal is going through these three sections here. There seems to be a lack of sensitivity, but that might be due to the fact that our plate voltage is low. So I'm going to do something about that and see if that gives me better sensitivity, and the tubes will work more efficiently at that voltage, going from 61, which I'm measuring, to 81. I resoldered the connections, reflowed or resoldered them. Some people call it reflowing, in the RF section and on the other side of this multi-band switching arrangement. And this piece of brown, it's like bakelite, a very thin piece of bakelite, was broken in the middle and pulling over to the left. So I clamped that and put some automotive epoxy type stuff on it, and that seems to be holding it in place. I might have to put more on if it is bending too much, but it seems to be holding pretty well right now. Right here on the bottom of the RF tube, right at pin, I guess it's the grid, which would be pin 6, I'm feeding in a 1 megahertz modulated signal, and I don't hear anything. That tube obviously has a problem. I moved the input signal to the output of the RF tube, which would be pin 2, and I have some response. I'm hearing a tone, a test tone on the loudspeaker, but I'm feeding in a pretty high level signal, so it's there's obviously a problem with the RF stage, and the converter tube seems to be working, as it does tune quite sharply. It tunes, but there probably is some amplification problems in the IF section too. So I'll be going down the line. Once I fix the RF tube problem, I'll be going down the line and trying to figure out why this radio lacks sensitivity. I have injected 455 kilohertz signal into pin 2, which is the plate of the converter tube, and I put in a fairly low-level signal, and it seems to be responding quite well through the IF section. So the problem is with the RF tube and the converter tube. The converter tube probably needs a bit more application, but the RF tube is completely dead. So that section needs work. I'm going to try and raise also the B plus voltage and see if that helps. It's only 61 volts, and I'm going to, on the RF tube, and I'm going to raise it to 73 volts and see what that does. Now that we've got the radio working, I'm going to align it. First, we're going to align the IF. I've got a signal generator set up for 455 kilohertz, AM mode 400 hertz, and approximately it's just 0.03 volts, and I'm loosely coupled through an alligator clip to the converter tube, just wrapped around the tube, and I've got wires, alligator clips at the speaker, and they are going to a VTVM. Now, we're going to measure for highest voltage, so I'm going to turn the volume up a bit. Actually, we're going to turn up the input signal a bit, and then we'll adjust these two IF bins for the maximum signal. So here we are, and we're going to use a fine tuning tool because those have very small, there we are. Try it again. This radio, considering it's 76 years old, did not need a whole lot of IF alignment. It was quite sensitive. Okay, there we are. That's good enough. So now what I'm going to do is I'm going to adjust the level of certain frequencies in the AM band or medium wave. So I'm going to set the signal generator to 1600. 1600 and approximately the same levels. And I'm going to check out, see what this little trimmer here. Let's just give that a little peek. One thing that's important to do when you are lining a tube radio like this, let it heat up for at least half an hour before you do anything, because the frequencies will drift as the radio changes temperature. And since I'm doing this out of the cabinet, the recommendations are to do it on top of, to do the alignment on top of metal that would be approximately equal in bulk to the batteries that fit underneath the chassis in the wooden cabinet. So I think I got a lot of metal around here. Okay, so that AM alignment is done. Next we're going to, here I'm going to check out 9.6 megahertz or the 31 meter band, and looking at it's right on 9.6 megahertz, so I won't have to adjust those 3 second down from the top. I found that the coils in the back there are for matching to the antenna. So I'm going to have to do, once the radio is in and hooked up to its wave magnet antenna, or the actual antenna that is in the radio, I'm going to have to peak those because they make an enormous difference in the signal level. So now, from now on, I'm just going to check the other bands and make sure they're accurate. I checked 11.8 megahertz on the 25 meter band, and it was right on. It was well on. Only needed to be adjusted a little bit. The sensitivity is so-so. It's quite a bit less than the 31 meter band, but that might just be that it needs to be adjusted to the antenna that once it's in the cabinet. Now 15.2 in the 19 meter band is right on, which we will just try peaking again. There we are. And we'll just leave it at that. Maybe just try the other one once. There we are. Now we're going to check the 16 meter band. The radio has excellent performance now, but the shortwave bands are dead, so I can't test it out. But just an example, the station I'm tuned to is 650, and it's right on.
The Portman Bridge.
98.
Really appreciate it.
1130.
One west just before 248.
730. 690.
There are 5 left-handed batters.
650. 600.
In which was set.
550.
For me, therefore,
so it's working very well.
Third baseman jumps in front, 1 ball and no strikes. Dominguez, as you might guess, as a right-handed pitcher, has had more success against right-handed batters as opposed to lefties this year. Is 1-0 just away.
That area on the east coast is putting a light to light bridge at the right decision. And so we're going through.
Here I'm receiving Radio New Zealand International at 11,725 kilohertz on the 25 meter band. It's coming in very well, and you can see there that the pointer is reading 11,725 there. Just, that's the third one down from the top. Just down 15, but 11,725 kilohertz. And considering that it's just using a whip antenna, it's quite amazing the type of sensitivity you get from that radio. It's that station is 7,000 miles away from where I am right now, and it's coming in just excellent. Here, probably get some more. See, it even gets to the point where it's distorted. It's quite listenable. Extremely sensitive radio.